Okay, so here we go with video 3, and the topic we're going to handle on this one is trapezoidal sums. So trapezoidal sum. And this is a method of approximation. So an approximation method. And we've seen approximation methods before for area. Should have said that for area. So I've started us with a graph that we're really used to operating on, f of x equals x squared, and it's a parabola. I just sketched it in red. And of course, we could integrate this thing and find exact area. And why don't we do that? Let's go, I think in class we went 0 to 4. So if we were to actually find the exact area on this, under this parabola, that would be x cubed over 3, evaluated from 0 to 4. We'd plug a 4 in. 4 cubed is 64. We'd have 64 thirds minus 0. And that's 64 thirds is, what, 21 and a third. And so that's the exact area, the space under the curve above the x-axis. However, earlier in the year, we were talking about Riemann sums, and we talked about right edge estimates with, say, something like 4 subintervals. And 4 subintervals is nice, and I chose it in class for ease of computation purposes. If we have 4 subintervals and we're going 1, 2, 3, and 4, we're going from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Each of those widths, of course, is just going to be a 1. And so there's my width. And then I'm going to multiply by height. And I'm going to multiply by 4 separate heights. And in this case, that constitutes taking 1, 2, 3, and 4 and squaring them, because those are going to give you the y values associated with those heights, which are ultimately the heights of those rectangles. And of course, in this case, that would result in an overestimate. That last rectangle is really a questionable rectangle. So we'll kind of square it out there a little bit better. And of course, there's an overestimate effect going on. So I'm going to take 1 and square it. That's 1. And I'll just write it with a little squared. Then I've got 2 squared, 3 squared, and 4 squared. Those are the heights of those triangles. So let's see, let's call those heights. And then the 1, of course, is a width. So I'm going to take 1, the width, and I'm going to multiply by each of those 4 heights, or an easier way is simply to add all those together. 1 plus 4 plus 9 plus 16. And when you add those values together, you've got, what is that? 20, 30. So we'd have 1 times 30. So R4 is 30. And that's an overestimate by quite a bit, actually. So we know the exact amount down here. And R4, which again we did really early on in the year, is an overestimate. We could also do L4, in which case you'd still have a width of 1 and you'd still have 4 heights, but these heights get determined by the left edge of the interval. So instead of 1, 2, 3, and 4, which are the right edges of the interval, when we go from 0 to 1, our left edge is going to be 0, and the left edge of the second gap from 1 to 2 would be 1, and the left edge on the third gap would be 2, and the final gap would be 3. And so those, when we draw those in, those are going to be underestimates because they're going to sit underneath the curve. And I mean, you can see that just by drawing in the rectangles. We've done that numerous times over the year, so I'm not going to draw all those in. But we have our width, we have our heights, and again here, we're going to compute that. We're going to get 1 times, and it's going to be 0, 1, 4, and 9. And there again, it's just an estimate for the area. This is going to be an estimate of 14. And in that case, this is an underestimate. So we have an overestimate and we have an underestimate. And a trapezoidal sum. The book presents it as a separate formula to be memorized, and it is, or can be, thought of that way. But in truth, all that formula is doing is taking the right plus the left and dividing by 2, an average. So it's taking an average of your right estimate and your left estimate and then taking them together and dividing by 2, so coming up with an average. I shouldn't try to get too fancy with how I talk about that. So 30 plus 14 over 2, which is 44 over 2, which is 22, which is actually a pretty darn good estimate. So you're kind of weighting a little bit over, that's a little bit under. And that's it. So that's our estimated value. And in truth, that's it. That is what a trapezoidal sum is. I'm not even sure I'm going to need to teach a separate lesson on this. And really, I just like to start review with it just to remind people that, hey, we have these methods for estimation. So this typically would get taught really early on, and I tend to save it for the end of the year just as an intro into our review, which this year obviously got changed a bit. And the one thing I would say too that I tried to cover in class, what you're doing here when you do that estimate, and I'll draw in our parabola again, and this is more of kind of a gee whiz, like this is cool type thing, and you know that I think everything that is the cool, but maybe you will too. When we're splitting it up into our 4 pieces, let's just look from the 2 to 3 piece, for example. So there's our 1, 2, 3, 4. If we use the left edge, it would be here. If we use the right edge, it would be here. If you take the average, what you're mathematically doing actually is connecting those 2 dots. And you're making a linear chunk. And there's a little separation between that line and the curve, but then you're drawing down, and you've created geometrically a trapezoid. And it's not the prettiest trapezoid I've ever drawn, but that, if I kind of draw it out here by itself, is what it would look like. It still has that same width of 1, but here it's actually got 2 pieces, 2 heights, I guess you could call them. One that comes from the left side being squared, and one that comes from the right side being squared. And so the area of a trapezoid is 1/2 base 1, so we're going to call that base 1, plus base 2 times the height. So 1/2 base 1, base 2 times the height. Well, lo and behold, that's just what an average of a left edge and right edge are. So we're taking the average of left edge, right edge, and then multiplying, technically by the width on this specific rectangle. So again, this is just kind of a gee whiz, that's neat type of thing. I don't want you actually computing it that way or thinking about it that way when you're asked to do a trapezoidal. When you're asked to do a trapezoidal, all you're going to do is you're going to take the left edge estimate, and you're going to get your 14. You're going to take your right edge estimate, you're going to get 30, and you're going to divide by 2, or take your average and divide by 2, and you get an estimate, and that's it. That's all a trapezoidal is. It does technically create a trapezoid shape, or it takes the average of the left and right, which kind of levels off the rectangle and makes it a linear kind of slanted function on top. But again, that's more just like a, hey, that's cool, and Clues thinks that's really interesting. So this is just kind of a fun fact type of deal, and it's why it gets called trapezoidal. But in truth, what you need to be responsible for is, hey, I know how to do a right edge, I know how to do a left edge, and guess what? I know how to do an average, and I can get a trapezoidal approximation that way. So please don't use the book's formula for memorizing. Just think, I already know those 2, and I'm going to take an average. And that's really it for this one.